This is IceCube, a telescope buried deep under Antarctic ice. It does not use mirrors. It does not look through a lens. And from the surface, almost the entire machine is invisible. IceCube was built to catch neutrinos, ghost-like particles that can travel through planets, stars, and entire galaxies almost without touching anything. So why would scientists bury a telescope under Antarctica? The answer is hidden inside the ice. IceCube sits near the Amundsen-Scott South Pole Station, in one of the coldest and most isolated places on Earth. Above the surface, there is only a small laboratory building. But below it, the detector stretches down through a cubic kilometer of clear Antarctic ice. Inside that ice are more than 5,000 light sensors, frozen onto long vertical cables. They begin almost a mile beneath the surface and continue even deeper, where the ice is dark, stable, and extremely clear. The strange part is that IceCube is not waiting for light from space. It is waiting for a particle. Neutrinos are among the hardest things in the universe to detect. They are almost massless. They have no electric charge, and most of the time they pass straight through ordinary matter as if it were not there. Every second, huge numbers of neutrinos pass through Earth. Almost all of them leave no trace. But very rarely, one of them interacts with an atom inside the Antarctic ice. When that happens, the collision creates a charged particle moving through the ice. That particle gives off a tiny flash of blue light called Cherenkov light. IceCube's sensors catch that flash. From the timing, brightness, and pattern of the light, scientists can reconstruct where the particle came from and how much energy it carried. That is why the detector has to be so large. A small detector would almost never see anything. Neutrinos are too elusive. To catch a few of the most interesting ones, IceCube uses the ice itself as part of the machine. The South Pole ice is not just a place to bury the detector, it is the detector, and this turns IceCube into a very unusual kind of telescope. Ordinary telescopes see light, visible light, radio waves, X-rays, gamma rays, but light can be blocked, absorbed, or scattered by dust, gas, and magnetic fields. Neutrinos are different. Because they almost never interact, they can escape from violent places that light may not fully reveal: exploding stars, black holes, neutron stars, and powerful cosmic engines far beyond our solar system. In 2017, an IceCube alert helped telescopes around the world connect a high-energy neutrino with a distant blazar, a galaxy with a supermassive black hole launching a jet toward Earth. That was a glimpse of why neutrino astronomy matters. IceCube is not just detecting particles. It is helping scientists trace invisible messages back to some of the most extreme environments in the universe. From the surface, it looks almost like nothing is there. A quiet building, a flat horizon, endless white ice. But deep below, thousands of sensors are waiting in the dark, watching for flashes that last only a fraction of a second. A telescope under Antarctica, using the Earth itself as a shield, and the ice itself as an eye. IceCube shows that sometimes, to look farther into the universe, you do not build higher, you dig deeper.